Hi everyone. Now we're going to see the geometrical significance of vector product. Earlier, we have seen the geometrical significance of dot product, that is the projection of one vector on another vector. Similarly, for the vector product also, we have some geometrical significance. Let's see what it is, okay? Now, first, consider a parallelogram ABCD. So this is a parallelogram of ABCD having adjacent sides as vector A and vector B. So one of the side is vector A and the other side is vector B. Similarly, its parallel sides are also vector A and vector B. So we know that to find a unit vector, we need to draw a perpendicular from A to B vector. So that we'll get the unit vector, that is A becomes A sine theta, right? Now, we know that the diagonal of parallelogram divides the parallelogram into two congruent triangles. So, here AC is the diagonal which divides the parallelogram into two congruent triangles. So, in triangle ADC, what does the area will be? Area of triangle becomes half into base into height, right? So here what is the base? Base is nothing but the B vector, that is DC, right? We want the magnitude. And what is the height? Magnitude of A vector into sine theta. So what does it becomes? Half of A B sine theta is nothing but magnitude of A cross B, because we are talking about the area. So we only need the magnitude of A cross B. Similarly, to find the in parallelogram ABCD, what will be the area? Now, as it divides the parallelogram into two congruent triangles, so area becomes twice of its area of triangle, right? Area of triangle ADC. Now, area of parallelogram will be magnitude of A cross B. So, these are the two main significance of vector product, that is area of triangle half A cross B, and one more is the area of parallelogram, that is A cross B. And both talks about the magnitude only, because we are talking about the area. Okay. In this question, it is given that A, B, C are the position vectors of vertices of triangle ABC, and we need to prove that the area of triangle ABC is this. So how to prove this? So this is the triangle with the position vector in the of vertices ABC are given, and we need to prove its area. So basically, what will be the area of triangle? Matlab any triangle. It becomes half into base into height. So here, obviously, we talk about the magnitude. Base is what? Let's take base as BA. If we take base as BA, what does height will be? It becomes BC. It's not necessary that you need to take base as BA and height as BC. Instead, you can take base as AC and height as AD. But one thing you need to remember is both the base and height should have the same initial point. Okay. So now it becomes half of BA is nothing but position vector. It becomes A minus B. Similarly, BC is nothing but C minus B. Now just multiply. You will get as A cross C minus A cross B minus B cross C. That's it. Because B cross B becomes 0. I already discussed you, right? In the properties of vector product. So now here it is A cross C. Okay. Next, A cross B can be written as minus A cross B can be written as plus B cross A. This also we have discussed in the properties of vector product plus B cross A. Similarly, plus C cross B. There is a property which tells A cross B is equal to negative of B cross A because direction comes into the account. This is the reason why it becomes minus of B cross A. So, uh, if you see the question, we got the required answer. That is, area of triangle is half of A cross C plus B cross A plus C cross B. Hence, proved.